Morning class, and welcome to this lesson on Newton's second law. Today we're going to be able to define Newton's second law and apply it to different types of problems involving forces. Okay, so Newton's second law, okay, and different types of problems involving forces. Now today I'm just going to give you a completely conceptual framework for this. I'm not going to actually solve any problems on this video. So Newton's second law. The net force on an object is proportional to its mass and acceleration. The net force on an object is proportional to its mass and its acceleration. So we already know about acceleration. That's m meters per second squared. Mass is measured in kilograms. And now we have force. So first off, let's define a force real quick. A force is any push or pull on an object. Any push or pull on an object. So that's pretty easy to conceptualize, I think. And so based off this law, we get this equation. We get F equals ma. This is the most important equation you are going to use in this class. I'm going to say that again. It is the most important equation you are going to use in this class. You're going to use this over and over and over again. Notice I drew little arrows over F and over A. That just means that these are both vectors. These have a direction. So force can have magnitude and direction. Acceleration can have magnitude and direction. Mass is just kilograms, and that's only going to be That's a scalar. It's only magnitude. So notice here that based off these two numbers, mass is in kilograms and acceleration is in meters per second squared. These are the units. Okay. So any problem that has kilograms, meters per second squared is going to be a unit of force. And we call that the Newton. And we give that the capital N sign. So when we talk about forces and I say I push something, like I push this pencil with a force of 2 newtons, that's what I'm talking about. Newton is Isaac Newton's name, and we name this unit of force after him. So forces you're gonna hear this word a lot. Newtons, newtons, newtons. Okay? Now, notice I said net force. Net. So net force, I'm gonna write this down here. Net force is the sum of all forces. So if we have an object here and has a force pushing it this way and a force pushing it this way, we'll call this 5 newtons and we'll call this 20 newtons, the opposite direction. The net force is going to be 15 newtons to the left. Okay, 15 newtons to the left. That is the net force. It is the sum of all forces. Let's say down here in this example, we have a force of 5 newtons up and 5 newtons to the right. Well, the net force is going to be the combination of these two forces. So it's going to be the resultant of 5 and 5. So this is going to be the square root of 5 squared plus 5 squared, which is the square root of 50 newtons there. So this would be the net force we're talking about. It is the sum of all forces. Okay, and so one of the biggest struggles we're going to have in this next chapter is making sure that we identify all forces. Okay, this is going to be our challenge. IDing all forces present. So we're making sure that we're looking at the correct net force, or the sum of all forces on this particular object. Okay, so net force. Notice we have acceleration right here. And then so some problems, so this is a hint, some problems will not give you acceleration. Some problems may give you, they'll give you final velocity, initial velocity, and time. So instead of saying F equals ma, F equals m, the change in v, over the change in t. So we're going to have to substitute these values in for that. And this can be for any of the kinematic equations. We learned there are three main kinematic equations that involve acceleration. So therefore, anything that involves acceleration can be plugged in for this. So that might make it a little bit complicated as well. So that being said, this is what force is going to be all about. This is the concept behind it all. That we have net force, the combination of forces, and F equals ma, mass times acceleration, and acceleration, we might just give it to you. We might say acceleration is 6 meters per second squared, or you might have to solve for that in itself. So this is the main piece of how to solve for Newton's second law.